Hi everyone, I'm going to walk you through how to use the Truss problem solver on Google Colab. The first cell here lets you clone the GitHub repository with all the .py script files that are required to run the program and import all the packages required to run the program. So run cell, cloning in progress, downloading XLSX writer, which helps us write into Excel files all our results. The next cell is the pre-processing cell. You have to first determine whether to do a 2D analysis or 3D analysis. Let's start with 3D analysis. Run this cell. Over here, you can input for each node the X, Y, and Z coordinates. Note the allowed units are in SI and imperial units are metric and imperial units are shown over here, mm and inches in this case. Similarly, you can specify the degree of freedom of each node, 0 being free to move and 1 being restrained. Similarly, the forces in x, y, and z direction, respectively, the initial displacements in x, y, and z, respectively. These are all float text boxes that only allow numbers as inputs. If you need to add a node, you can click this button. An entire row is added. If you want to remove a node, click this button and the last row would be deleted. Similarly, for the elements block, the first node I shows the local node 1 for that particular element and the local node 2 for that element. E is the Young's modulus of the element and A is the area of cross section of that element. Similarly, you can add elements or remove elements. Be sure to click submit before moving on to the analysis cell. Once you have submitted, run the analysis cell. You can see the output of nodal displacements, nodal reactions, and element axial force, stresses, and strains. The plotting functions are only available for 2D structures right now, so we won't be running this cell. This cell allows you to download your whatever results you want into an Excel file. The results I have chosen are the nodal coordinates, the element connectivity matrix, and the displacements and stresses of each element. Once this cell is run, you can find the truss.xlsx file to your left by clicking here, this one. You can double click to download the file. Alright, we're gonna do a run for a 2D analysis as well, just to show you the plotting functionality. Run this cell. As you can see, the input format has changed to only accommodate for 2 dimensions in coordinates, degree of freedoms, forces, and initial displacements. The element block hasn't changed. Once this is a example file for a 2D truss. Once you submit this, run analysis, you can see the nodal displacements in mm or inches depending on how you have input here. Nodal reactions, element axial force, stress, and strain. We will run this cell to check the undeformed shape, deformed shape, and stress diagrams. Just to play around, say you change the force to minus 20,710. Submit this file. Be sure to run analysis before running this cell again. And as you can see, the force direction has changed, as well as the deformed shape, obviously. You can try a few more things like release degree of freedom X for node 1, submit file, run analysis, plot diagram. As you can see, there's a roller support here. This doesn't look too good, but you get the point. Stress diagram, red indicating compression and blue indicating tension. Similarly, you can run this file again and this file would be updated here. So that's about it. Thank you.